Okay, so now I will proceed. So already we have our ESXi host configured. So its IP is 192.168.0.102. So we'll try to log into the host using vSphere web client. Okay, so in the previous class we were discussing about the um, dashboard informations, and here currently you can see the the particular host ESXi host has 6.4 gigahertz of RAM. So only 1% of the resource is being consumed by the hypervisor, and the server has 4 GB of RAM. So nearly 2.88 GB is being used by the hypervisor itself. And coming to the networking part, so by default, whenever you install the hypervisor, by default, a virtual switch is getting created. And in that virtual switch, the physical network card will be assigned as the uplink adapter. So using this uplink port, the virtual switch can get connected into the physical network, so that the physical network machines can access the virtual machines that is connecting to this virtual switch. And also on this virtual switch you have two default port groups created. So one is named as a VM network, which you can use it for connecting your virtual machines, and the other one we have the management network. Basically this is not just a port group, it is basically a VM kernel port, which means that, so this is the network interface of the hypervisor, because the physical adapter is being used as the uplink port for the V switch. So this physical adapter cannot be directly used by the hypervisor itself. So obviously the hypervisor needs network connectivity, so that at least you can connect the remote session of the hypervisor for configuring and management. So for that sake, the hypervisor kernel will have a virtual network interface, so which is here named it as VM kernel port. And for that basically this VM kernel port is named as a management network, and basically this network this virtual network interface is going to be used for the management purpose. And also we have configured the static IP address in the previous session. We have just configured this IP as the static IP for this management network. So using this IP only, currently we are logged into the ESXi host. And also coming to the storage, see basically when you are creating a virtual machine, a bunch of files are going to be created. So basically virtual machine is collection of virtual hardware files. So when you create a virtual machine, so a set of files are going to be created, and that files need to be stored somewhere. So basically here in VMware, uh, it supports a file system called VMFS. As like in Windows, you have the NTFS file system. In Linux, you have extended 3 file system. Similarly, in VMware, they have a file system called a VMFS file system. So basically, your physical hard disk can be formatted with VMFS file system. So any disk that is formatted using VMFS file system, so that is here it is called as a data store. So basically you need a data store to store your virtual machine files. As like in Windows computers, you need to have a logical drives created where you can store your files and folders. Similarly, so here in VMware ESX, so to store your virtual machine files, so basically you need a VMFS data store or an NFS data store. So currently you can see there is no data stores available. So the first thing is you can create the data store. So basically in the older version of ESX, generally while you are installing the ESX hypervisor, you'll be selecting a hard disk in which the VMware hypervisor can be installed. So in that particular hard disk, so the VMware hypervisor installation will take a small portion of that disk, and the remaining portion will be unallocated, and that unallocated space will be configured as the VMFS data store by default in the older versions. But in this particular version, after installing the hypervisor, the space which has been already uh, uh, made free, or the remaining space after the space taken for the installing hypervisor, the remaining space was not configured as the VMFS data store by default. So in that case, you can create the VMFS data store manually. So if you want to create a VMFS data store, basically your physical server should have additional hard disk. And here under devices, you can see what is the number of hard disks the virtual machine has. So currently this physical server has only one virtual hard disk. Basically here we are using the virtual machine as the yeah, hypervisor physical server. So currently there is only one hard disk, and this disk is already used to install the uh, ESX. So for now, we need to have one more hard disk, so using which you can create the VMFS data store. So first of all, what I want to do is let me create a uh, additional hard disk for my ESX hypervisor. So let me go to the settings. Let me add a new disk. I'm adding the hard disk. So this is in case of virtual machine. If it is a physical box, obviously you need to attach an additional physical hard disk. I'm creating a new virtual hard disk. Maybe I can give the capacity something like 100 GB. Then okay. And now let me rescan the device. Okay, maybe since this is a hypervisor, it need uh, a reboot, or let me try after shutting down, because sometimes it will not uh, recognize the hot add disk. So let me check, and here we can see the hard disk is added. I just want to make sure it again. Yeah, so I have the second hard disk added, and also I have the thin provisioned disk. And let me power on the host again. So basically the uh, after adding a new physical hard disk, sometimes it may require a reboot, but most of the cases it might not require a reboot. Since this is a virtual machine, it requires a reboot, but mostly in production environment, when you are running your VMware ESX on physical boxes, so you can attach the new hard disk, and where those new added hard disks will be recognized by the hypervisor automatically. So where you can do hot adding or hot removal. So now we'll just wait for this server to come up. Okay, and here our server is up and running. And let me log into the host again. Okay, so let me go to storage. Under devices, you can see the 100 GB disk is visible here. And now using this disk, you can create a new data store using the option new data store. So I can give whatever the name I want. I'll just give it as ds-01. I'm going to use the entire full capacity for this data store. So under data stores, so currently we have the disk file. Sorry, the data store is visible here. And now basically this system is ready for creating the virtual machines. Okay, and also I'll just show you my physical host. I have one more physical server in which I'm running my ESXi. Okay, so this is my physical box. So in which I have 12.8 gigahertz of processor and 32 GB of RAM and 319 GB of disk. And in this already I have uh, two virtual switches, and also I have a few network port groups created. And also here I have uh, one data store, and also I have a bunch of virtual machines. So initially we'll start with creating a new virtual machine. Just want to delete this. Okay, so let me start with creating a new virtual machine. So the options are quite simple. So whenever you select the option, after selecting the virtual machines in the left pane, in the top ribbon menu on the right side, you can see the create or register VM. Click on that, and here you can select create a new virtual machine, then give next, and you can give any name for your virtual machine. Let me give the name demo VM01. And also while creating the virtual machine you need to select the compatibility. So if you already have the VMware infrastructure running on the older versions, so where you want to create a virtual machine compatible with the older version, so in that case you can choose the older version. But for now I'm going to go with the latest version. And also you need to choose the guest OS family. So choosing a guest OS family is very much important. So based on the guest OS family you are choosing and the guest OS version you are choosing, the appropriate hardwares will get created. So example, if I'm creating a Windows 10 32-bit. So what happens is while creating the virtual machine, 32-bit processor will be created for this virtual machine. Later, if I try to install any 64-bit operating system of Windows 10, definitely the processor will not be compatible, so the installation will fail. And in other case, and here currently I'm creating a Microsoft Windows 10. So basically it is a desktop operating system. So for desktop operating system, basically the hard disk type will be SATA disk or ID disk. So basically for Windows 10 computers, the ID drivers or SATA drivers will be inbuilt in the operating system itself. And maybe if in case I'm choosing any server operating system, say example, I'm choosing Windows Server 2003 32-bit. Since this is the server operating system, um, the hard disk type that will be created for this virtual machine will be the SCSI hard disk. So after the creation of the virtual machine, later I'm trying to install any desktop version of operating system like Windows 10 or 7 or Windows 10. So basically Windows 7 or Windows 10 will have only the ID driver or the SATA drivers. So the desktop operating system will not have the uh, SCSI drivers. So after creating this virtual machine, later if you are trying to install any desktop version of operating system, so where the installation or the operating system will not be able to detect the hard disk, so it will say there is no hard disk found. So based on the guest OS version you are choosing, appropriate hardware is going to get created. And later if you're trying to install any different version of the guest OS, so obviously you're going to face the installation issues. So to avoid that, so basically you need to choose the appropriate guest OS version which you are going to install in this virtual machine. Is that clear for you all? If there is any questions, please let me know. I'm waiting for your response.
No questions.
Okay, that's great. So let me proceed next. And here, while creating the virtual machine, you need to choose the destination where the virtual machine files has to be parked. And here I'm choosing the data store, the only data store I have. If you have multiple data stores, so you'll have the options to choose. So where you can have your uh, virtual machines stored maybe in a different data store also. But for now, I'm going with the data store, the only data store which I have. Then give next. And here you need to define the configurations for your virtual machine. So what is the number of processor or number of core, that is number of core per socket, and the number of CPUs, that is the virtual CPU you want to allocate for your virtual machine. So based on your requirement, you can choose whatever the number you want. But the number basically decided based on the number of logical processor your physical host has. Number of logical processor in the sense the number of core your physical server has. Say example, your physical server has 16 cores. So which means that your physical server has 16 logical processor. And obviously here you'll get 16 as the numbers listed over here. And based on your requirement of your virtual machine, you can choose whichever the number of sockets or core per virtual machine. And for now, I just go with one. And also, if required, you can enable hot plug of CPU. And maybe if required, you can reserve the some amount of the processing, that is the clock speed. And based on your requirement, you can set the limitation also. And also you can define the shared priority. By default, the shared priority will be normal. Maybe based on your application's requirement, you can go with the high, low, or medium. But whenever you go with the when you are trying to change the shared priority, so basically you need to have a proper calculation, that is the hardware uh, calculation is very important. The capacity planning is very important. So based on the calculation, so you can choose whether you need high, low, or medium, or custom. And similarly, you can also specify the amount of RAM you want for your virtual machine. So let me give it as 2048. And also you can specify the hard disk capacity for your virtual machine. So while specifying the hard disk configurations, so you have three options. You can go with thin provisioned disk or thick provisioned disk. When you're going with thin provisioned disk, basically the disk file that is going to be created will be 0 KB. Based on the usage, the file size can grow maximum up to 48 GB. But initially the file size will be 0 KB. And if you're going with thick provisioned disk, so immediately the 48 GB will be allocated from the data store in which the file is being created. So thick provision disk, basically it's like a reservation. So either the resource is getting consumed or not, but still the resource is completely allocated for this particular virtual machine. And here you have under three thick provisioning itself, you have two options: the thick provision lazy zeroed or eager zeroed. So if you're going with, I believe you might be aware about zero filling or low level formatting. Are you aware of this? Can anyone answer my question? If you are aware about zero filling or low level formatting or disk wiping, haven't you
No
heard?
idea.
Okay, see,
No idea, sir.
whenever you have any data in your hard disk, after formatting the hard disk, will you be able to recover your data?
Yeah, yes, sir.
How it is possible?
Mm, it's possible. I think.
Basically, using some tools, you can do that. But
Yeah,
how these tools are able to do this? See, generally, when you are formatting a disk, your data are not completely erased. So basically, the file system table alone is getting erased and a new file system table is being created, but your data are still remaining in the clusters. So using this kind of tools, these tools can read each and every cluster, and it can identify what data are available or what data are stored in the clusters, and using that you can recover it back. So uh, whenever if the management decides of scrapping a server or scrapping a disk, so if just like that, they cannot give this hard disk to the scrap vendor, because uh, anyone who is getting this hard disk, so they may be uh, uh, they will be able to uh, retrieve the data of your organization, so that should not happen. So to avoid that, we will perform this zero filling. So basically the zero filling or disk wiping or low level formatting, so all these terms are nearly same. So basically every organization before scrapping any disk, so they will perform the zero filling or disk wiping. So what happens is basically when you're performing zero filling, null data, that is empty data, will be filled in all the clusters. So which means that when empty data or null data are filled in all the clusters, so obviously the older data, the existing data will get erased, so that all the clusters will be filled with empty data. So later using any tool, you will not be able to recover the data, exist older data. So that is what basically the zero filling is. So when you're creating a virtual machine disk, so whether that particular disk should be a zero filled disk or that need not to be zero filled. So lazy zero will not perform zero filling while creating the virtual machine, whereas thick provision disk, while the disk is getting created itself, it will perform the zero filling, whatever the space that is being allocated for this virtual machine. So all the clusters will get zero filled, so that older data will not be uh, able to recover after the creation of this disk file. So based on your requirement, you can go with thin provisioned disk or thick provisioned lazy zeroed or eager zeroed. It's up to your choice. And similarly, while creating a virtual machine, you can select the network port group in which the virtual machine has to be connected. As like when you in your physical infrastructure, the network team will choose in which port this particular server has to be connected. That is basically based on the VLAN configurations. So in which project this virtual machine is going to be used. So and that particular project belongs to what VLAN, and in which port the particular VLAN is configured. So based on that, the server's network cable will be connected to the appropriate VLAN port. So similar like that here, you can use the network port groups for configuring the VLANs. So based on the project of or the based on the virtual machines project, so you can choose the appropriate network port group. So let me choose Windows Lab, or you can choose whatever you want. And also, while creating a virtual machine, basically you need to, after creating the virtual machine, you need to install the operating system in the virtual machine. That is, the guest OS has to be installed. So usually in a physical system, if you want to install the operating system, so you'll insert the bootable disk, bootable CD or bootable USB drive. So using which you can install the operating system. Since this is a virtual machine, you'll have multiple option. You can use the physical CD-ROM drive of the physical server, or since this is a virtual machine, it can also use ISO files as the removable devices. So if you have the ISO file, maybe Windows 10 or whatever the operating system's ISO file. Basically, the ISO file has to be copied into the data store of your ESXi host. And if you have your ISO files inside the data store, and then those ISO files can be mounted as the CD-ROM for the virtual machine. And here, as I said earlier, you can see the two options. One is the host device, which is nothing but the CD-ROM drive of the physical host, and data store ISO file. So where if you have the ISO files in the data store, so you can locate that. Whenever I choose the option, so it gets into the data store browser. So where already I have uploaded some of the files over here, and from here I'm choosing the Windows 10 ISO file. Then let me select. So this particular file that can be used as the CD-ROM for this virtual machine. and then give next. And this is the final summary of your virtual machines configuration. Any configuration changes has to be done. You can go back and change. Otherwise, if everything is okay, you can just press finish so that the virtual machine will get created. And here we can see our demo VM is created. Is that clear for you all?
Yes, sir.
Okay. So I believe you got a better understanding about the virtual machine and how the virtual machine has to be created and what are all the uh, parameters that has to be taken into consideration while creating a virtual machine. And now the next stage we need to understand about is the virtual machine files. So just a while before we were discussing that when you're creating a virtual machine, a set of files is going to be created. So now we need to understand what are all the files of a virtual machine or what are all the files that is getting created for your virtual machine. And can anyone tell me where does the virtual machine files is getting stored or from where I can verify the files of a virtual machine?
So it should be stored in the ESXi, right?
Yeah, obviously that should be because we have created the virtual machine in the ESXi host. Obviously, it should be in there in the host, but in the host where I
Okay.
can see the files,
You mean the path,
correct? Not the exact
path
path
and
or
folder.
the location.
Mhm.
See, while creating a virtual machine, we have selected a particular data store, isn't it?
Yeah,
So basically, the virtual machine files should be found on the same data store.
same data store. Yeah. So,
So,
suppose if I'm creating a VM,
mm,
say COM, okay.
mm, mm.
So it will be stored in COM folder.
Exactly, exactly. So
Yeah.
the data store which you have selected while creating a virtual machine, in that particular data store, you can see the file or a folder, basically a folder. You can just go to the storage and in the right pane in the ribbon menu, you can see the data store browse option. When you click that, it will take you to the data store browser. So where you can find a folder in the name of your virtual machine. So inside that folder, you can see the files of your virtual machine. Is that clear? And here,
Yeah, yes.
okay, I want you to note down this particular file. I want to give some explanations about each and every file. So I want you to note down this particular file name alone. So demo VM. So demo VM one is our name of our virtual machine, and the extension is very important. That is .vmdk. So note down this particular file name. Along with that, you note on one more file name. Demo VM01 hyphen flat.vmdk. Note on this file name too. I want you to note down two file names. One is demo vm.vmdk. The another file is demo vm hyphen flat.vmdk. So basically, these two files combinedly form the virtual hard disk. So when you create a virtual hard disk, basically two files are created. Only one file is visibly seen here. The other file, that is demo vm hyphen flat.vmdk. So this file is basically a hidden file. You cannot see in this browser, but there will be two files for a single virtual hard disk file. Is that clear?
Yeah. So
Hmm.
VMDK is nothing but a virtual machine data
Disk file,
disk. Okay. Mm,
virtual
mm,
machine disk file.
okay.
So these two files form the virtual hard disk of a virtual machine. Okay, why the two files are there? what informations are stored in these two files. So basically this particular file which you visibly see here, virtual machine name.vmdk. So this file stores the configuration information of the virtual hard disk. What is the configuration information of the virtual hard disk? What is the type of hard disk? Either it is a SCSI hard disk or a SATA hard disk or a SAS hard disk. That is the type of hard disk.
CPU, network,
And no, no,
all
not
kind of
C. No, no, no. It doesn't
hmm,
have other information. It has only the information about the hard disk.
storage.
Yeah, the hard disk of the virtual machine,
Okay.
not the entire storage. So it has the information of the type of hard disk that was created and the capacity of the disk and the number of cylinders, number of read write heads. So all the information related to this hard disk. So that is being stored inside the file. Okay, it is not going to have any other information about the physical hard disk, or it is not going to have any other information of the virtual machines like the virtual machines CPU, RAM, or it is not going to store any other information. So this file will store only the information about the particular virtual hard disk. Okay, so while creating the virtual machine, we have selected the option that is we have selected a thin provisioned disk. So this information also will be stored inside this file. So this is a thin provisioned disk, and this is a SCSI hard disk, and this is the hard disk with the 48 GB of capacity, and this hard disk has four read write, four cylinders. It has four read write heads. So only these informations are stored inside this file. Got it?
Okay.
And okay, where does say after creating the virtual machine, later I may install the operating system or I may store some files or folders. And where will those information be stored? And those informations will be stored inside this file. So basically those information we call it as the raw data of the virtual machine. So whatever the data that is stored through the virtual machine, so those data we call it as the raw data. So the raw data are basically stored inside the flat.vmdk file. Got it?
Yeah, okay, sir.
Okay. And you can make a note of this file, virtual machine name.vmsd, and also along with that you can note down the another file name, snapshot.vmsn. I'm sorry, snapshot.vmsn. So the one file is demo vm.vmsd and another file is snapshot.vmsn. So basically these two files are used for virtual machine snapshot. Later we'll discuss about virtual machine snapshot. So for now you can just make a note that these two files belongs to virtual machine snapshot. If you have noted, please acknowledge me.
This is for
Okay.
snapshots, right?
Yeah, these two files are for
Okay.
snapshot.
This one means snapshot.
Correct, correct.
Virtual machine.
Okay. And you can take down this file name, virtual machine name.vmx. So this is a very important file of any virtual machine. So this is the core file of a virtual machine. And this file only contains the information of the virtual machine's overall configuration. I can just show you the open and show you the file. I just download this file now. I just save it somewhere. Okay, let me save it under downloads itself. We can open this file with a notepad. Okay, where is the open with? Yeah, here it is. I'm opening it with a notepad, and here you can see. So this file contains the configuration information of the entire virtual machine. So here you can see the version of the virtual machine, hardware version, and the NVRAM of the virtual machine, and further information which is clearly, which can make you understand further. And here you can see the type of hard disk is SCSI hard disk, and what is the hard disk file name? So demo VM. Okay, and in which network it is connected? Okay, and what is the display name of a virtual machine, and what is the guest OS architecture, and all the other information, including the CPU and so on. So basically, this particular file contains the, and here you can see the floppy information, CD-ROM information, all the information. Got it. So basically, the, and also here you can see the CPU informations and power state informations. Okay, so basically, this file is the configuration file of a virtual machine. Whenever a virtual machine is powered on, hypervisor will first read this file. Hypervisor will first read this file, and based on the information available in the file, so those resources will be allocated to the virtual machine. Got it? So this file is the core file of a virtual machine, or you can also call it as configuration file of a virtual machine. Since this file contains the configuration information of the virtual machine, and whenever you power on the virtual machine, hypervisor will first read this file, and based on the configurations or based on the informations available inside the file, so the respective resources will be allocated to the virtual machine. Got it? If there is any more questions, please let me know. Okay, so whenever you create a virtual machine, only these three files are created, but a virtual machine contains a little more other files also. So, but few files will be created at the first power on of a virtual machine, and few files will be created uh, whenever the virtual machine is powered on, and when you power off the virtual machine, few files will get deleted automatically. So here I just want you to show the same. First, let me try to power on the virtual machine. Okay, let me power on the virtual machine, and here immediately you can see some more files are created, and here you can see 1 2 3 4 5 6 7 8 9 files are there. Let me power off the virtual machine, and immediately you can see some files will get removed automatically, and only now we can see only 5 files are available. So basically, when you a few files will be created only when the virtual machine is powered on, and those files will get will get removed immediately the virtual machine is powered off. Is that clear? And now you can take down note of this file name with the extension .nvram. So this file is basically the BIOS file of a virtual machine, as like you have BIOS chip in your physical machines. So similarly, where the physical chip stores the BIOS informations. So similarly here, this particular file stores the BIOS informations of the virtual machine. And this file will get created when you power on the virtual machine for the first time. Once the file is created, then the file will remain permanent, and immediately when you power off the virtual machine, still the file remains. So this particular file will be created only at the first power on time, and once the file has been created, it will stay permanent. Okay, so this is basically the BIOS file of a virtual machine, which stores the BIOS informations. If there is any more questions, please let me know. Okay, so let me power on the virtual machine again. Okay, and here you can see a bunch of files. I want you to make a note of these two files, this one and this one. And basically these two files are related to the configuration file. See, generally when you open any file like Word document or an Excel document, so a temporary file will be created. Similarly, now this file is in open state. So for this file, a temporary file is getting created. So that is this one. And the other file with the extension .vmx.lck is a log file of the configuration file. So when the log file is created, so this particular virtual machine cannot be registered in any other host. So to protect a virtual machine file being registered in any other host, so this log file is created. So whenever there is a log file created for a virtual machine, so the uh, uh, virtual machine files cannot be used by any other host. And also now you can see the other file with extension .vswp. So for with this extension we have two files. So one file uh, is the one file's name starting with the virtual machine's name, another file name starting with vmx dot virtual machine name, but both the file has the same extension .vswp. So these two files combinedly form the RAM of a virtual machine. So these two files are the RAM files of a virtual machine. Okay, now take a note on this. These two files are the RAM files of a virtual machine. And out of these two files, so basically this particular file, which starts with the uh, VMX hyphen virtual machine name. So this particular file is the configuration file of a RAM, as like the configuration file of a hard disk. So here, this is the configuration file of a RAM. And the other file, which starts with the virtual machine's name and with the extension .vswp, which is going to store the raw data information of the RAM. And also you can see the capacity. So for this RAM, for this virtual machine, we have allocated 2 GB as the RAM capacity, and this file size also will be 2 GB. So where this file is going to be used to store the raw data of a RAM. So whatever um, whenever the virtual machine is processing, doing any process. So basically for any process being executed, so some data are going to be stored in the RAM. So those informations are going to be stored inside this file. And these two files basically will get created when the virtual machine is powered on, and immediately when the virtual machine is powered off, so these virtual machine files will get deleted automatically. Since the RAM is not going to store any information permanently, so unnecessarily it need not to occupy the space from the data store. So that's why whenever you power off the virtual machine, these two files will get deleted automatically and will get created once the virtual machine is powered on. Is that clear? And also we have other file with the extension .log, that is the log file. So this file is going to store the log information of a virtual machine, log information of the virtual machine in the sense when the virtual machine is powered on, and after powering on the virtual machine, what are all the configuration changes has been made, or something like after powering on the virtual machine, I have mounted an ISO file, or I have disconnected the network, or I have connected the network. I have added one more hard disk. I have removed one hard disk. So all the configuration changes towards the virtual machine. So those log informations will be stored inside this file. And basically for every power on cycle, a new file will get created. So basically we have powered on this virtual machine for 3 times. So basically 3 files created. And maybe when I try to power off the virtual machine and power it on again, I just power it off again. And currently you can see there is only 3 log files created. And now I'm powering on again. And here I can see there's one more file created. So for every power on cycle, a new file will get created, and immediately when you uh, and it will also not store all the log files. So it'll show only the last 7 log files, not the older logs. So older log files will get removed or deleted based on first in first out policy. So only last 7 log files will be stored in the data store. Is that clear? If there is any more questions, please let me know. Okay, so apart from this, there will be one more file with extension VMTX. That is your virtual machine name dot VMTX. Uh, demo VM01 dot VMTX. So basically, this is the file of template file. Basically, we'll create the template of a virtual machine, and this is the virtual machine's template file, as like you have the configuration file of your virtual machine. Similarly, when you create a template from your virtual machine, you will not see the .vmx file. Instead of that, you'll have this file with the extension .vmtx, so which is basically the configuration file of a template. And similarly, you can also uh, uh, suspend a virtual machine. So suspending a virtual machine is equivalent to hibernation. So basically, when you hibernate a system, it might be a laptop or a desktop. So basically, the RAM informations will be copied to the hard disk, so that whenever you power on your system back, it will be back with all the open files or open windows. So that is basically the hibernation. So when you hibernate a machine, so basically what happens is the RAM informations are copied to the hard disk and stored permanently. And when you turn on the system again, so the RAM informations are loaded back to the physical RAM, so that you'll get all the open windows and open consoles back. So similar like the hibernation. So here for virtual machines, we have a thing called a suspend. So when you suspend a virtual machine, the same thing is going to happen as of the hibernation. So again, here also, when you suspend a virtual machine, the RAM informations are going to be copied somewhere. Where it is going to be copied? So inside a file with extension vmem. And when you suspend a virtual machine, this particular file with extension vmss will be created. So this is basically the suspended state file, virtual machine suspended state file. So it stores the suspended state information, and the RAM informations are copied inside this file with extension .vmem. So .vmem contains the copy of the RAM when the virtual machine is suspended, and VMSS basically it has the information of the suspended state. Is that clear? If there is any more questions, please let me know. Okay. And immediately when you power on the virtual machine, that is when you are resuming back from the suspension. So immediately those two files will get removed. I'm just refreshing. And here you can notice, so there is no .vmm file or VSS file. And that's all about the virtual machine files. If there is any more questions, please let me know. Okay, so if there is no more questions, so then this is going to be the end of today's session, and we'll continue the remaining topics in the upcoming sessions. Until then, bye bye.